Okay, let's go ahead and get started. We're getting down near the end of this, so there are really 2 lectures left. One I want to do is storing kind of complex information in files, which is a special topic that I want to cover today. And the second one is related to that, and that's going to be some simple network programming that I want to get some coverage in. There is a class later on in the degree sequence where you do much more complicated network programming and communication programs. But we'll do something simple, but that'll be next class. This class we're going to focus on storing complex information in files, and as we'll see next class, there is some overlap between those 2 topics. All right, so let's get started with files. So far we've looked at file I/O functions, and those file I/O functions gave us a set of capabilities to read from or write to an open file. So we would open a file, and we would open it either for reading or writing or appending, and then we would either write data to it if we opened it for writing or appending, or read data from it if we opened it for reading. And all of the I/O was based on character data or string data being kind of pushed out to that file or pulled in from that file, because that's essentially what files are. Files are kind of a sequence of byte values that we can either open and then read through, or we can open and then add to and write to. So an example of that was like the code that I have below there, where I say open test.txt, open it for writing. That's the mode. That's going to open it and gives us file pointer or file handle. And then with that file object, we can then write data to it. In this case, because I opened it for writing, that's going to write that string into the file with the new line character, and then we can close it when we're done. So that's going to write that single line into that file. Now, that's useful. And in previous programs, like our kind of tile map module examples that we did previously, we would store data into the file by kind of encoding the data in some sort of structured format that we came up with, and then we would read it back from the file by opening that, reading the line in, and then decoding it from that format. And so I suppose we could quickly switch to looking at that some of that code here for a second. Let me switch. Let's see, tile examples. So let me just find one of these and then load it and take a look here. Okay, so let me switch the screen over to this. And then you'll be able to see it here quickly. All right, so here's the kind of thing that we're talking about. So here we made this kind of tile map module that previously. And notice that one of the things that we did is we had to file and from file. So let's look at to file first. So in the to file version of this, we basically went through all of the attributes of the module: the map width, the map height, the width and height of each tile, the color we wanted for the bad tile color, the map itself, all of the lines of that. We went through and wrote out all of those things, and then all of the texture files that we wanted that kept track of what tile went with what kind of thing, like bricks and ladders and whatever. And then we wrote all of that to the file. We opened the file for writing, wrote it all out, closed the file when we were done. And then loading it, we kind of did the opposite, where we basically opened the file for reading. We then basically went through and read all of the lines of the file, and then we went through each of those lines and we said, hey, if it's this, or if it's a blank line or a comment, we skip it. Otherwise, we read the part before the equal sign, the part after the equal sign, and we pull it in and we set it to the thing. So this is kind of doing the opposite. But notice in this case, we had to do all of that ourselves to write it to the file and to load it from the file. So in other words, if I were to change this object and add some more attributes to it, I'd have to come down here and change the to file and from file to add those attributes into the file to be saved and into the from file to be loaded. But we could do all of that, and that works fine. But that gives us kind of only this one way of doing that we have to write it all ourselves. So let's switch back to the presentation here for a second. All right, so going back to the presentation, what we would like to do in this case is, are there other options besides writing all of the code to do this stuff ourselves? And the problem here is we had to write all that code ourselves to both encode the data when we saved it and decode it when we load it. And we could do that, but the problem is it's going to get more and more complicated as I have more and more things that need to be put in there. And that was only for just one object. What if I have not just the map, but I have enemy data I want to save in the save data? What if I have the player data for what level they're on and all the other stuff? So I might have a much more complicated thing than just the stuff for that one map object. So what if I wanted to save a list of objects or the entire game state? The way we did it before, we'd have to write all of the code to do that ourselves. So we'd have to write it for every object. We'd have to have a to file and a from file. We'd have to make sure we get all of the objects. In some cases, we might even have a variable number of objects, like bullets. If we want to say, save the game as it is right now, and there are 50 bullets on the screen, we might have to encode all of those in some sort of file structure. Or enemies. There's a dozen enemies on the screen right now. Here are their positions. Here's their health. We'd have to save all of that, and that could change depending on when we do the save. So we'd have to still write it all ourselves if we did it that way. Now, what we're going to do is look at what if there's a way to convert it into those strings to store in the file for us. So rather than us having to do it, there was some sort of special feature that did it for us. And it would be especially useful. You could both encode and decode really complex data, like lists of things that could change sizes, dictionaries that automatically associate a key value pair for us. If we could have a way that it automatically did that without us having to do it for variable numbers of things and different kinds of complex data, that would be great. Now, that brings us to a concept in programming known as serialization, or in some languages they call it marshalling. But the idea is you take some object that exists in the computer's memory in some way, and you put it into a serialized representation or a line of bytes. So we have this thing that's in memory. Parts of it might be stored in different parts of memory, but we want to serialize it. We want to turn it into a string, essentially, that can then be reloaded and decoded later. All right, so there's several ways of doing that. We're going to look at a few of them today. All right, so here are some of the options. Custom, that's what we did previously. And notice that we had to do all the work ourselves for that. But there's some other things that we could do where it does some of the work for us. So for example, Pickle is a standard module in Python that's designed to work specifically with Python objects, and it can serialize almost anything in Python that we throw at it. Now, the problem with that one, though, we'll see later, is it's not really, while it's a standard Python module, it's not really cross-language, so we couldn't use that for other languages. It's also not human readable, which we'll see in a second. Now, there's some other options. JSON is one that provides a little more readable way of serializing objects that was borrowed from JavaScript. A little more limited than Pickle, but a similar concept, but it's cross-language compatible. But it's also cannot do some of the things Pickle can do. Same thing for MsgPack. And MsgPack is a really good kind of third-party library that is supports multiple languages. It's really fast and it's really efficient, meaning its representations are really small, which makes it good for things like multiplayer network games. And then XML has been around for a while, which is kind of this extensible markup language. It has its roots in like HTML with tags, and it's a alternate to the other ones. I don't like using XML for network stuff. It's okay for data files, but it's a little more complicated, a little more explicit, meaning that the data files are larger. But JSON and Pickle and MsgPack are a little more compact and a little faster. Okay, now custom ones, we said we did that before, and we'll just briefly touch on that. But basically, we write the code that encodes the data as a string or a file, and we write the code that decodes it. And we did that before. We just looked at the code, that to file and from file. Notice that those, switching back to that just for 1 second, that also had to string and from string that were part of that. Okay, so in this case, again, it's up to us to write all of that ourselves. Now, Pickle, on the other hand, it's a standard module that does most of the work for us, and it works with almost any Python object. So it allows us to convert any Python object into a string of bytes, kind of like a byte array, and it allows us to convert back from that byte string, that byte array, back into a Python object that is identical to the one that was encoded. And other programming languages have a similar feature. It's usually called serialization or marshalling, but Pickle is the one that's specific to Python. So let's take a quick look at how it works. So the way Pickle works is first we have to import the module. So import the Pickle module. Once it's imported, we can use the methods, and there really are a set of methods here beyond what I'm going to present today. But the first two, pickle.dump, which sounds a little funny, but essentially you pass it in a reference to any object. This could be a number, a string, an instance. We can put whatever object we want there. And then the file handle we want it to be dumped to. Now in this case, this file handle, that file would already have to have been opened. And to use dump, it would have to have been opened for writing or appending. So we can essentially say, hey, in this file, write the serialized representation of that object. And then to do the opposite of that, we can do pickle.load of the file handle, and that's going to return to us an object. So in other words, we have a way to stick an object into a file, a way to pull an object back out of a file. But again, note that the file has to be opened with the correct mode for either writing or reading. And one thing to note is you can open one file and do dump multiple objects. So you could dump object 1, and then object 2, and object 3, and object 4. So that could be like the player list, the bullet list, the treasury list, the high score stuff. You could dump a whole bunch of things in and then reload them all. But remember, the order matters. So the order we dump them in needs to be the same as the order we load them back into the program from. Now, the idea, there's another way to use Pickle where rather than it dumping directly into the file, it just gives us that byte string directly. And that's, you just add an S on the end of dump, so pickle.dumps, which sounds even stupider than pickle.dump. But pickle.dumps, we pass an object. We don't have to pass a file handle because it's going to return to us the string representation. And this could be useful for network code where we don't necessarily want to dump it to a file. We want to dump it into a string and then send the string across the network. On the other end of the network, we're going to take that string and do pickle dot. This should be loads, not load. But that loads it back and gives us the object back. So dumps and loads are the two things we would have for this. So here, let me just, I'm going to fix that quickly here. We are here. I'm going to fix that right now before I forget. All right, so now let's go back to the presentation. Oh, back to the beginning. Go back to where we were. There. All right, so dumps and loads are opposites of each other. One takes the byte string, gives us the object. One takes the object, gives us the byte string. Now, that allows us to do other things with those byte arrays, like we could then send those over a network, or we could gather a list of those, put them in a dictionary, and then we could encode that dictionary and save it if we wanted. But we could use those pickled objects with our own file specification if we wanted to, or send them over a network. Now, one of the things that's cool, since everything is in Python is some sort of object in some way, that's not necessarily true in other languages, but in Python, everything is an object in some form or another, including the code itself. That gives us a whole lot of possibilities with how we can use this pickle object. So let's look at a few. And I'm going to focus right now on using these dumps and loads to see what those representations look like. So in this case, let's say we have this high score variable. and it has the value 10,000 in it. And so to pickle that, I can do pickle.dump, so just pass the object in, and it's going to have this pickled score. And if I print that out, it looks like this. Notice it's just a string of bytes. And so this B in front of the double quotes means this is a byte array. And so the first value is the character value hex 80, followed by 04, followed by 995, and these are hex values, followed by 04, followed by 00, 00, 00, 00, 00, 00, 00, 00, 00, and then a capital M, and then the last one here is a hex 10. So this whole thing is the representation of this value 10,000. And notice it's a binary format, that these have non-ASCII characters. When it prints it out on the screen from print, it's kind of taking that 80 and putting it, showing it in this kind of expanded form. But it's really just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters long. Actually, these two have 14, 15 characters long because that single quote in that period at the end count. But so we've got all of those characters that are in there. But now if I unpickle that, if I take that same string and I use loads on it, it'll say unpickled score. Now if I print that, we're back to having the 10,000. So we took the 10,000, encoded it like this, decoded it back into this other variable, printed that variable, we get 10,000. So we get the same object out that we put in. But in the interim, it got converted into this weird serialized format. Now, one of the things that's cool is we can not only just pickle or encode numbers, we can do strings. So here's a string, player name, player 1. We dump that. Here's what it looks like. We load it. This is what, and now we're back to having the string player 1 again. So note that pickled objects are represented as these kind of binary byte string representations. And they look weird when you look at it. You can see some of the data in there, but it's got all this other data wrapped around there that kind of gives us information about what kind of object it is, and how long it is, and things like that. So there are other things in there. Notice the ending with a period says that's the end of the pickle representation. But let's look at a few more things that we can pickle. Lists. So here's a list of things. And in this, I actually did something fairly complex. I have a list that's a list of tuples that have inside of it, each tuple has 2 items, which has a string and a number. So we can think of this as high scores. Player 1 is the name. There's a score that went with it. That should maybe say player 2. But player 1 maybe played twice and they had 10 and then 20, but player 3 got 30, and then I played and I got 40. So I can pickle that, even though it's a complex object that has a list of a variable number of these objects or items, where each item is a tuple that has 2 items inside of it. I can still just use pickle on that, say dump that high scores thing. And this is what it looks like in the pickled form. Notice it's got a bunch of weird characters in it. But if I unpickle it, I'm back to a list just like what I started with, a list of tuples that looks just like the original one. In other words, 1, 2, 3, 4 items. Each item has a tuple of 2 sub-items, 1, 2, and the values are the same and the strings are the same. So Pickle can handle that kind of organization and hierarchy without problems. You can have lists of lists. You could have lists of numbers, lists of strings, lists of tuples that have strings and numbers like we had here. It's all up to us with how we want to put that stuff together and put it into that data object. All right, Pickle can also encode classes, and it can encode functions, which is a little bit weird to think about. In this case, we're actually pickling code. So we can take this code for this object and pickle that. If we unpickled it, we'd get the class back out, and we could use that class to make things. Or we could take the code for this function, this distance function, and pickle that. And we could unpickle that and get it back if we wanted to. Now, there are some dangers to this. One of the things here is this is not pickling all of the stuff that's in here for the code. For example, you notice there's no operators and things like that. It's basically saying, hey, there's a class, it's called this, it's in this namespace. But one of the things to notice is you could pickle the code directly, but I'm not going to show how to do that right now. That kit does give you the ability to have pickled stuff that's in a file that gets loaded into your program, and then it does something to your code. And that can be a security vulnerability, which is actually a thing to be cautious about when using Pickle. That don't just unpickle something and trust that it's the code that you put into it, because somebody could have injected something malicious into that. Okay, now here's another couple Pickle examples. Here's an instance. So here's an instance called of this ball object, and that ball object is this one back here. So it just has an X and a Y. That's all it has in it. It's got these two methods, the constructor and get position. But notice that I could make an instance of that ball object B1, and I could pickle it. And there's my instance. That has inside of it the X and the Y value being stored in there. And notice that I could also make a list of those objects, instances, and I could pickle all of that. And if I were to unpickle this, I'd be back to having a list of 10 of these with whatever values they had stored in them. So it's pretty cool, but you have notice that this is completely unreadable. We have no idea what the values are that are in there, which could be useful as well. But looking at this, if I were to look at that in a file, it just looks like a bunch of random junk thrown in the file. And you could look up the Pickle specification and figure it out, but it's not really human friendly. It's not readable. It's designed for Python to read. Also, dictionaries can be pickled. So here's a dictionary for a player object, like name is player 1, class is elf, score is 0, health is 100, their X and Y are 400 and 300, speed is 0.1, the direction is 45.4. So all of these things have a key and a value, just like all dictionaries. We can just do pickle.dumps of that dictionary, and there's what it looks like when it's encoded. So dictionaries can have any key value pair, including you could have values as lists or other dictionaries. You could have the key be both strings if we wanted to, or numbers if we wanted to. Really, it's whatever we want. But that can be useful for save game files that you could say, for example, have all of the data in a big dictionary that encodes the game state, pickle that, and then when we want to load it, unpickle it, and the game state is back to how it was before we saved the game, or when we saved the game. Okay, now, this is something that's really cool and really easy to use in Python that works with the Pickle module called the shelve module. And shelve lets us store objects in a file by using kind of this keyword strings without us having to do it ourselves. So behind the scenes, it uses Pickle and a dictionary, and it does all of the work for us. But notice it's really easy for us to use it. So let's look at how we'd store data in it. So to store data, we just have to import shelve. And then notice to open the shelve, we just do shelve.open. And notice I don't have to specify reading or writing. I don't have to specify which one. It'll handle all of that for me. I just say, hey, open the file game_items.dat. And then in there have items, score name is Paul, or high score name is Paul, high score value is 1,000, level checkpoint is 10, best time is 109.32. And then if I do items.sync, it's going to take anything that I put into that dictionary and assign a value to, and it's going to push it into that file for me. And then I can close that file. And if I want to read stuff out of that file, it's even easier. So to access the data in the thing, I just open the file, and then I can just access those just like they were in a local dictionary. It'll pull them out of the file for me. If I change one, I can call sync again. It'll update it. But notice that that's super easy to store things, and anything that's pickleable can be stuck into that one of those shelf objects. So for example, I could really just have a dictionary that has all my game state stuff that comes out of that file. I could update them whenever I want to, and if I call sync, it'll save that off. You could also have multiple shelves open at once. You could have a shelf for the game items, one for the high scores, one for the game settings. You can have as many of these as you want open at one time and interact with them however you want. The main bug I see people make with this is changing things and forgetting to call sync. If you don't call sync, sync is like Control S on a word processor that says, now take a snapshot of that and save it. Okay, so that makes storing game state data really easy. But the one drawback with using shelves and using Pickle is, okay, let's go back for a second. Look at what this stuff looks like when it gets stored in the file. It's this complicated mess of stuff that is, if we wanted to open that file and edit it or understand it, or use it in another program other than Python, programming language other than Python, it'd be difficult to do. So the drawbacks here between using Pickle and Shelf, well, the advantage is it's super easy, but the drawbacks are that it uses this binary format. And the problems that creates is that they're not human readable or human editable. The second problem that creates is they're not usable by other programming languages. So if we wanted to use Pickle and have some other programming language that took the file we created and use it, it's not really designed for that. It's designed to be Pickle works with Python. So pickled functions and classes could pose a security threat if we're not careful about that. Pulling code out of a random file and executing it could create a security hole. And also, the pickled data is quite lengthy. Again, going back and looking at this here, this dictionary here explodes into all of this stuff here that is hard to read, hard to understand, and not exactly nice and compact, which is especially important for something like network code. But it's still probably the easiest way to store any kind of Python data that you want. But let's look at some alternatives to that solve some of those problems. So first off, let's look at JSON quickly. So JSON, also known as, which is short for JavaScript Object Notation, was a kind of serialization method created to exchange data between programs in JavaScript over the internet. But it was designed, unlike Pickle, to be human readable once the data has been encoded. And it's also not Python specific, which means we could have programs of different languages use it, which makes it a lot more universally applicable to a lot of different problems. It's also relatively compact. It's easy to encode and decode. It's easy for a human to look at and understand what it's in. So let's take a look at how to use it. Now, the cool thing about JSON, the JSON module in Python, is it really works just like the Pickle module, meaning that we have dump and we have load, which work the same way. And then if we wanted to use the string version of those, we have dumps and loads, which give us the encoded string, or take the encoded string and turn it back into an object. But one of the things is the main difference isn't how we use it here, it's how it encodes the data behind the scenes. And also note that what we can encode is a little more limited in JSON than it is in Python, because JSON was designed for JavaScript. It can't deal with things like Python functions, Python classes, and it can deal with Python instances, but we have to look at that in a very certain way in order to use it in a certain way to get it to support this. All right, so using JSON, the things that we can encode are kind of limited to the following kinds of things. Dictionaries work fine, and that's one of the workhorses of encoding stuff, whether you're using Pickle or JSON, is to use dictionaries. Key value pairs, the keys have to be some object, the values have to be some object, or a value, but we can use dictionaries. We can also make lists of things. And just like in Python itself, in the programming language, dictionaries use curly braces, lists use square brackets, and then values can be a string, a number, either an integer or a float, an object, meaning one of these things up here. It could be a true, a false, or null. And notice that in Python that's true, false, and none, but we can encode, those get encoded using that. So we can have dictionaries of things, lists of things, and then values that look like strings, numbers, arrays, true, false, and none. So notice that there's no provision in JSON for encoding things like functions, classes, or instances, but we're going to get around the instances one here in just a second. Okay, so here's some example of encoding things with JSON values. And notice here I did a score of 100 and a speed of 15.2 and a string of player 1. And you'll notice when I call dumps on those that they're readable. 100 looks like 100. 15.2 looks like 15.2. And the name player 1 looks like player 1 in double quotes. So these retain their readability in a way that Pickle does not. So all JSON encoded values are going to be human readable, no matter what we encode, no matter what type of thing out of these we encode. They're going to end up in human readable ASCII text that we can read. All right, so let's look at a dictionary. So here's a dictionary, the same one we did earlier. The player, class, score, health, X, Y, speed, direction. When we dump that in JSON, we can read this, and there's a curly brace. Name is player 1, class is elf, score is 0. Notice this looks a lot like the code that encoded it. So we could, if we were to store this in a file, we could open that file and find the name player 1 and edit that if we wanted to. And when we reload that, it would pull it back up with that edited version. So it's not binary, it's human readable, easily understandable, and editable. You can also do lists. Here's the high score list we had earlier with the list of tuples. We encode that. One thing to note that when we dump that, there's no distinction in JavaScript between lists and tuples, so they all just get stuck in as lists. So this becomes lists of lists rather than lists of tuples, but it's the same hierarchy and the same data encoded in there. Okay, and here's a thing that I said was a difficulty, that we can't encode an object instance like we could with Pickle. And if we try, so here we made a B1 is one of these an instance of this ball object, same ball object we had earlier. But if I do JSON.dumps, I get this trace back that says object of type ball is not JSON serializable. It doesn't know how to do that. But what I'm going to show you right now is this clever way that you can encode that. And in this case, we really just have this X and a Y as the attributes of this. But we could write our own method to encode it and take the X and the Y, put them in a list, make our thing to decode to pull them back out of the list. But there's a really cool way to do that that's very clever and very Python specific. And that's that all object instances in Python have the attribute value stored internally inside of this special variable called __dict__. And essentially, if you go back and look at this variable, self.x, self.y, there's a dictionary that says x holds this value, y holds that value. So it's a dictionary actually storing all of the attributes. And we can get access to that because it's stored inside of this specially named __dict__ dictionary that every object has those. So here, notice what I could do is I could say b1 equal ball, and I could do JSON.dumps b1.__dict__, and that's going to save the x and the y. And I could actually load those back up from that too, and say b1.__dict__ equal JSON.loads, and then the string, this string, and it will overwrite the x and the y values that are there. Now, the one thing about this is we'll only work on values inside of here that are in the dictionary, that the value part of that are serializable themselves, or JSON serializable themselves. But if we wanted to, we could custom encode those and then still store them. Okay, so summary, JSON allows us a way to do the same thing that Pickle does, but it's both human readable and it's pretty fast too. It's fairly compact, about the same as Pickle. It doesn't take up any more space than Pickle does. And has a few limitations, but we can get around those if we need to. Now, one problem that remains with both of those, they aren't really as compact as maybe we'd like, especially for network programming. If we're writing a network program, it's really important to keep the size of the data traveling across the network as small as possible. And neither JSON nor Pickle were designed to be compact and use a small amount of space. So one thing that I want to look at today, I'm just going to present this briefly, is a module that I like, a library I like called MsgPack. And what MsgPack does is it's super fast, very compact, better, uses much less space than Pickle or JSON. And it's also cross-language like JSON is, meaning that you could have a C++ program on one end and a Python program on another and have them talk using MsgPack. All right, so let's look at MsgPack. And MsgPack does not come with Python. It's not part of the standard install, so you'd have to install it yourself. So looking at how that works, it's not human readable like JSON, but the data that's encoded is really tiny. It's much smaller. It's very compact. All right. Notice it's easy to install. You can install it from the command prompt by using pip, saying pip install MsgPack, MsgPack. That will install it. Or if you're in a Python shell, you can install it directly. This is a trick that I use sometimes. You can say import pip._internal, and then do pip._internal.main, and then pass to it install MsgPack. Notice that's the same thing that you're putting on the command line here, but we're passing it directly to the main function of pip that we loaded into Python. And I like to do these from inside of the a Python shell, just because I don't have to worry about the path being set for pip correctly or something like that, or getting a wrong version of pip for whatever version of Python I'm on. But this will work most of the time. Okay, so how do we use it? Interestingly, it works the same way as the other two. It has load, it has dump, or it's got dumps, it's got loads. So notice here, same example we did with JSON, 115.2 player 1. We can use MsgPack.dumps. Notice how much smaller. This is a single byte that gets dumped out to store that score of 100. And notice down here for this speed, 15.2, we just get a few bytes here, much smaller than that giant bunch of stuff that we were getting with Pickle. About the same as what we get with JSON for that number. And then for the string, very small amount of stuff. So notice that the usage of MsgPack works like Pickle, works like JSON, but the encoding method is different. Okay, MsgPack works with dictionaries, it works with lists, and you'll notice that the size of this is much smaller than what we had with the other things. Same thing with this. This list is much smaller than what we had with the other ones. Much more compact. Not human readable, but much more compact. And to give an idea of the sizes, MsgPack will usually have about 30 to 60% of usage. And looking at that relative to JSON and Pickle, here are some examples. So if I take that high scores example that I had back here, which was right there, and I encode that in MsgPack, it's 38 bytes, where in JSON it was 65, in Pickle it was 61. So it's about not half the size, but pretty not too far off of that. So somewhere around 55% of the size. But now let's look at this one for this ball1__dict thing that we had. That was actually, I don't know where that was, but that had the X and the Y value in it. But notice that was 11 bytes in MsgPack. In JSON, it was 20, so it's about double the size in JSON. And look, it's 54 if we dump that object, the B1 object, using Pickle. So we're about 5 times the size here that we are with MsgPack. So again, that size reduction, cross-language compatibility make MsgPack a really useful alternative for serializing data, either to store in data files or for network communication for serializing and deserializing that data. Okay, so here's the summary. Each of those methods that we looked at there have advantages and disadvantages. A common method for making the save file is to put all of the data we want into a dictionary like GameState dictionary, and then encode that using JSON or Pickle, Shelve, or MsgPack. And if you're going to use Pickle and the Shelve module, we probably don't really need to put it all into GameState. We could just stick all the things in parts of the GameState in there under key value pairs. And for excuse me, and for simplicity's sake, I would say using Pickle and Shelve, if you're sure you're always going to do stuff natively in Python, makes sense. But I've kind of gotten away from that and prefer to use JSON just because it makes files that are readable from other languages. And you never know when you're going to need to have your data maybe be read by something else. But for simplicity, it's hard to beat using the Shelve module. For compactness and cross-language compatibility, it's hard to beat MsgPack. And for readability, it's hard to beat JSON. So they each kind of have their place, some advantages and disadvantages for each. So it's up to you how you want to use that. There are other options as well, such as XML. I'm not going to cover XML today, but XML makes these really verbose kind of things that can have nested tags inside of a nested hierarchy. So you could have like player has the player object tag will have an end player tag, and in between those we'd have like the player name, which would have player name start, the name of the player name close. You can also have attributes associated with those things, but it's a much more complex thing. I'd suggest looking that up and getting familiar with the concept of how XML works. But for the stuff that we're doing in here, I think one of these three will work fine. You can also have hybrid approaches where you use a mixture of those, JSON things stored inside of XML tags, or Pickle and shelf objects storing serialized things that were serialized with MsgPack. Those hybrid approaches can be useful and allow some of the best of different worlds here, but I would suggest looking at the pros and cons of each. Pick the one that best suits what you want to do for your game, but it's hard to beat just using the shelf module if you're doing Python only programming. Okay, well that's all I was going to cover today. Next class, I'm going to do a quick primer on some network multiplayer game programming stuff in Python, and then from there, that's the last lecture. You'll just work on your lab and your presentation after the next lecture anyway, and make sure you get all that stuff done and be ready for the final exam. And I will post a study guide for the final exam soon, so keep an eye out for that as well. And that's all for today. So stay safe, and I will be in touch soon with the final lecture.